Hello everyone, welcome to another video from 3G 4G explaining different generations of mobile technology. Now these different generations of mobile technology is much more complex than most people think because people generally just know about some things about 2G, about 3G and 4G, but it's a bit complex, and we will try and look at most of these different technologies. But as you can guess, it's very difficult to cover all of them in one small video like this. So let's start from the beginning, what I term as 0G or pre-cellular. The first The first mobile system was the mobile telephony service, which was introduced in 1946 in the US by AT&T, and it was commercialized in 1947. By 1948, there were around 5,000 subscribers, and they used to make around 30,000 calls each week. In 1965, a more improved version, which is the improved MTS IMTS, was introduced, and this removed the need for operator and improved the capacity. Improved systems at the same time started to appear in Sweden, USSR, etc. Now, this is how a 0G or a pre-cellular mobile phone looks like. There were other pre-cellular systems. So the one which we talked about was the one in the US, the MTS. In UK, there was Post Office Radio Phone Service. Again, as I said, there was IMTS. There was another service in USA which was competing with MTS and IMTS. There was a system in Norway, OLT, one system in Denmark, and ARP in Finland. In around 1947, in December 1947, Douglas Ring he proposed a structure for mobile cellular systems, and what he suggested is an area. So the map here, which you can see, is from the Long Island, which is in New York in US. What he proposed is the areas in can be divided into small circles, or the areas where you can actually install an antenna, and it can provide coverage to an area which is shown in the circle, and this laid the foundation of cellular system. uh, so you can think of all these circles, if you just make so as you saw overlapping areas at the edges, you can say like these are all hexagonal shape, and this is where the term cellular systems come from. In reality, these are all circles, right? They are not hexagons, but you just show them as cells or hexagonal cells. The first generation of mobile system, uh, this was known as AMPS, Advanced Mobile Phone System. It was introduced in US in 1978. It came to Israel in 86 and Australia in 87. Now, the 1G system had lots of issues. So first of all, there was no encryption. So anyone can eavesdrop. So you could have a radio, and you can tune the radio, and you could be listening to people's phone conversations. And there was no real security. Like you have SIM cards today, there wasn't real SIM cards. So anybody could actually clone a system. So you would have fake mobile phones racking up bills for people who were using the service, and it was also very inefficient technology. So AMPS was superseded by digital AMPS DMs, which is a 2G technology, which we will have a look later, and it shut down in around 2008. uh, this is Dr. Martin Cooper, who was the part of team to show a proper first mobile phone, which is also known as the brick phone nowadays. You can only find it in museums. But what happened is 1G laid the foundation of cellular network. So the first thing it did was it used licensed spectrum. So till now, uh, the cellular systems in 0G didn't use a licensed system. So they just looked at some spectrum which was available, and they started using it and hoping that nobody else uses it, because otherwise there would be interference. 1G created the licensing norm. So all the spectrum that was used for 1G was licensed. There was also frequency reuse. So neighbor cells used different frequencies to avoid interference, as you can see in the picture on the right hand side. And it also defined the basic architecture of cellular network. Now remember, in 1G and even in early 2G, the focus was only on voice calls. So all the cellular system needed to do was connect to a PSTN landline system. The second generation, so the first generation, when it started becoming a bit successful, there were different second generation systems. In the US, the amps evolved to digital amps. Uh, so it was a TD-MA based technology. There was another system known as CDMA1 or IS-95. This was championed by Qualcomm and it was based on the CDMA technology, which is the code division multiple access. In case if people were wondering, TDMA was time division multiple access. It's a bit difficult to explain these concepts in this video, but you can always look it up on Wikipedia or some other websites. So CDMA1 evolved to CDMA 2000, which is a 3G based technology, which we will look later. So these are the American systems. Now CDMA1 was also used in some other countries in addition to the US. So there was one in one operator in Japan and one in China, and there were some other countries, but it wasn't very popular. In Japan, they had their own version of 2G, which was called the PDC, Personal Digital Cellular. Again, it was only very specific to Japan, which was actually launched by NTT Docomo. The most popular 2G system is the GSM, so which we still use. It was introduced in 1991, first deployed in Finland and then also in UK. But it is and it was the most popular 2G system. Most countries in Europe and Asia they used this 2G system, and there were only two frequencies which were mainly standardized. There are some variations, but generally it uses 900 or 1800 megahertz spectrum. Again, this was originally designed for voice only, and SMS was added much later in 1995. Even though it was standardized around 1985, nobody saw a use case for SMS. People used to wonder like, hey, what can you do in 140 characters? So it was launched much later. Uh, there was also support for data, but think about it, the support for data was only for things like fax. So people used to think, oh, I can actually use a mobile phone to send a fax, right? And that was the need for data. So it had a circuit switched data, and which used to give a maximum data rate of 57.6 kbps. It's sort of equivalent to a dial-up connection from your landlines, in case if you are old enough to remember one. Now we are not going to look much at the other technologies like the American or the Japanese one, because as I said, the most popular 2G standard was GSM. But GSM needed to evolve, because when people realize, hey, we can do data uh, on these phones, mobile phones, uh, GSM had to evolve and have a data path which was known as the GPRS, right? So GPRS was an enhancement, and nowadays any phones, even though you might call it a GSM phone, which you buy, is supports at least GPRS. So you can do some kind of a data. A theoretical maximum data rate is 170 kbps, but practically it's around 40 kbps. Now you might laugh at it saying like, hey, that's a really low data rate and why would we use it nowadays? But some people may remember the original iPhone was a 2.5G phone. It wasn't a 3G phone. So it only supported GPRS. So when you were out and about and you could do data at a very low data rate. Of course, when you connected to Wi-Fi, you can do a much higher data rate. But the original iPhone, you had 2.5G connectivity. There are also further enhancements. So what you have is the edge or enhanced data rates for GSM evolution. In theory, it supports 473.6 kbps, but practically it's more like 100 kbps. So when you have a phone, when you have your smartphone and you are in some kind of a rural or remote area, or maybe I don't know, outside the cities, where you don't have good 3G or 4G connectivity, sometimes you see on the top where it says what kind of technology it's using. Sometimes it says G, and generally when it says G, it's saying that it's supporting GPRS, and when it's saying E, it's for edge. Now, in around just before the year 2000, ITU, which is the United Nations Specialized Agency for Information Communication Technologies, ICTs, they decided that hey, we need to create a framework for the next generation system, and this was called IMT 2000. Now this picture, which is not a great resolution picture, is from the original paper back from the year 2000, and what it's trying to show is like a vision where you can have your mobile phone which connects to all different kind of networks, like it can connect to, I don't know, maybe satellite or satellite backhaul. You can connect to macro cell, micro cell, pico cell in buildings. You can have high speed uh, rail connectivity, and all kind of different things were possible. So as you can probably read, it says 2 Mbps like picocell and indoor, 384 kbps pedestrian and low speed vehicular, 144 kbps at high speed vehicular. This was just a vision, which is the IMT 2000. When we talk about 3G, 3G is actually a marketing name. The actual technology name is IMT 2000, but of course you won't find it being used by most people, because most people are not even aware, or it's too complex. Like if I say like, hey, this phone supports IMT 2000, you might just get more confused. And the intention was, once ITU defines this IMT 2000, so all the local standardization bodies, like say for example ETSI in Europe, ARIB in Japan, TIA in the US, they can all come together and they can form so these regional bodies can form consortium and partnerships. And once you have this consortium and partnerships, that means you can achieve economy of scale, right? So you can have standardized phones which can be used in multiple markets, which will bring the cost down. This was the vision. So as a part of this IMT, the third generation systems, there was a 3GPP2, third generation partnership project 2 body which was formed, and most of the members, and they focused on technologies which were more particular to the US market, right? So the CDMA 2000 was an evolution of IS-95, the Qualcomm technology, 1G technology, and it's called evolution data optimized. And of course this was further enhanced to EVDO, Rev A, Revision A, and Rev B. The other body that was formed was 3GPP, and 3GPP had two systems. So the one which you see as 3G nowadays is the UMTS, the Universal Mobile Telecom System. It's based on WCDMA, it uses frequency division duplex, and it's the foundation of 3G systems worldwide, except some networks. So some of these networks used CDMA 2000. But there was another technology which is supported by 3GPP, called the TD-SCDMA, time division synchronous code division multiple access. This was designed for China because China wanted to have their own standard for 3G. So rather than let them have their completely own standard, 3GPP supported the TD-SCDMA, which is also a narrowband TDD system. So 3GPP also defined a wideband TDD system like the FDD UMTS, but nobody implemented it. There wasn't any interest. So TD-SCDMA was a narrowband version of this technology, and it was only deployed by one operator, which is TD-SCDMA. But we are not going to look at 3GPP2 based technologies, and you will know the reason why. It doesn't really have an evolution path, so let's not worry too much about it. And we're also not going to look at TD-SCDMA because China Mobile is a wholehearted supporter of 4G LTE system, and TD-SCDMA also doesn't really have an evolution path. It was an experiment which did not succeed very well. So 3G, the normal UMTS, had different evolution steps as well, because the release 99, which is the first 3G system, it only supported 384 kbps downlink and uplink in theory. In practice, the data rates were quite poor. So it was evolved to 3.5G HSDPA, which supported much better data rates in downlink but same uplink data rates. Then it was further evolved to support much better uplink rates in the 3G 3.6G HSUPA. And then there were enhancements which are all called HSPA plus. I've given it different numbers, 3.7 and 3.75, etc, etc, and you can see the different evolution in data rates. Now most of the phones which you have, when your phone is just on 3G, it will show 3G, but when it's doing HSDPA and probably HSUPA, it will show a sign called H. When it's doing HSPA plus, any of them, from release 7 onwards, it will show H plus, right? So when you see this different like little character on the top of your phone, you know exactly what is it referring to. At the time of fourth generation, remember the 3G system were actually called IMT-2000, the standard name. So ITU decided to define requirements for 4G, and this was called IMT-Advanced. This picture is a Venn diagram, and it's showing like how IMT-2000 evolved to enhanced IMT-2000, which is the HSDPA, HSPA plus, etc, etc. But now it needs a new mobile system, the IMT-Advanced. So it can support much higher data rates mainly. So the focus was much higher data rates. So you have to remember, by this time iPhone was launched and Android phones were launched. So people started using more and more data on their phones, and they realized that 3G system was not up to up to giving higher data rates, right? So the data rates were limited, and also it was very power hungry. So there was a need for a much more advanced system. So that's why this is IMT Advanced, and the marketing name for this is 4G. So there are there were three different 4G technologies that was actually submitted to the ITU for IMT Advanced. One was the evolution of CDMA 2000. It was called Ultra Mobile Broadband. The another one was the 3GPP part, so from GSM to UMTS, now LTE. And the new entrant was a technology called the IEEE Wireless MAN, or 802.16, which is also known as WiMAX. The problem with UMB was there wasn't much support from different operators, because 3GPP or the 3G was the most common, most popular 3G technology. So every vendor operator wanted to have the same technology, so you can get the latest phones faster, right? UMB, everything was slow, and because a lot of proprietary Qualcomm stuff was in there, it had to be supported by Qualcomm. So UMB died, right? So there is no 4G path of 3GPP2. 3GPP2 only supports till 3G EVDO technology. And WiMAX, even though it was promised to be a great technology, and in fact it was a great technology without legacy baggage of other cellular technologies, the problem was there wasn't enough support from operators, and it sort of died too. So these two technologies never did any proper 4G rollout. There were some operators that were considering UMB rollout. Some operators did roll out WiMAX, but because there wasn't enough support, these both technologies died. And the most popular 4G technology was LTE. So as I says, as this picture says, all roads lead to LTE. Uh, Regardless of what technology you have, you could evolve to LTE or LTE Advanced. LTE Advanced, we'll look at it, LTE Advanced, in a minute. But the 4G LTE was the winner. Now, there was a lot of debate as to LTE, whether the initial version of LTE, whether it's really 4G or it's 3.9G, right? Because IMT-Advanced had certain requirements, and the main requirement, if you see in this picture, was the downlink and uplink data rate should be at least 1 gigabits per second. But the initial LTE devices that were available, right? So 3GPP works in different releases. So this was the 3GPP release 8. Some of you may not know about these 3GPP releases, but for those who understand, this was the first version of the LTE technology. And the maximum data rate you can get is 150 Mbps in the downlink and 50 Mbps in the uplink. Now this is the theoretical. The practical data rates would be much lower, right? So there was a lot of debate saying like, hey, is this really a 4G technology, or whether you would call it a 3.9G technology? So I prefer to use the term 3.9G for the actual LTE. So to make it an actual 4G technology, what the standards did is they came up with an improvement called carrier aggregation. And what carrier aggregation allowed was to combine different spectrum pieces together. So it's like, combining small individual pipes to make a bigger pipe, and you can combine up to 5 different carriers to make up to 100 megahertz pipe, right? And this way you can actually improve the data rates and you can make LTE a technology. And that's what this particular picture shows. So in theory, now in practice, it's still not meeting that 4G requirements, but let's not worry about theory, about practice. In theory, uh, with this, up to combining up to 5 carriers can give you a downlink of 3 Gbps and an uplink of 1.5 gigabits per second. Now this is a really high uh, amount of data transfer, and it's only in theory because it expects a device to have an 8 by 8 MIMO, right? It's basically saying 8 antennas. Transmitter should have 8 antennas, receiver should have 8 antennas, and you don't have this. So this is just theoretical, but let's not argue over these things. So this is fine. This is the real 4G, we can say. So LTE or the 3GPP technologies have been evolving. So you had the initial LTE, which was release 8. Then you had LTE Advanced, which was release 10. And then you have LTE Advanced Pro, which was part of release 13, and it's also referred to as 4.5G. So you may have heard the term nowadays being used called gigabit LTE. Gigabit LTE is more of LTE Advanced Pro technology, and it evolves further to 5G. So in very simplistic terms, you can think of LTE Advanced Pro is even more carrier aggregation, right? You can do carrier aggregation between licensed spectrum and unlicensed spectrum, like 5 gigahertz Wi-Fi spectrum, but it's probably too much detail to discuss in this video. And what we are going to get next is 5G. It's interesting because 5G is a standard name, as well as it's not just a marketing name, but it's also a standard defined by 3GPP. But as you remember, we're discussing about IMT 2000 for 3G and IMT Advanced for 4G. So for 5G, what we have is IMT 2020. So because it's supposed to come in theory in 2020. Now if you look at this picture, which is from one of those ITU documents, and it basically shows the comparison between 4G and 5G. So if you look at it, is basically showing that 5G will be much better and much more efficient than 4G, right? So you're getting a much better data rate, you're going to have a lot more connection density, right? The end-to-end latency will be much lower, traffic volume density much higher, high mobility, high peak rate. But again, this is in progress. It's still in theory. It's not yet been finalized. So you can summarize 5G, three main requirements of 5G. So first is the mobile broadband. So you want to have higher data rates, so you have to optimize the network for data rate. The second is you want to have a lot more devices connect to your network. So while we talk about only people, but you also want machines to connect to the network, and these machines, there will be a lot of machines, right? So you must have heard the term machine to machine or internet of things. So your chair can have some kind of connectivity, your bin can have some kind of a connectivity. So there will be a lot of different kind of devices and gadgets and cars. Everybody will have some or the other sensor, and your fridge and the microwave and your cooker. So you want all of these to connect to the network. Some can argue actually, this opens the door to hacking and things like that, but let's not worry about it. So you want to optimize for connection number. And finally, you want to optimize for delay. So for really mission critical communications, you want to have really low delay. So people are talking about sub millisecond latency. Again, it's a very tough ask from this technology, but that's the theory. So you want to optimize the network for the delay. So in summary, so again, if I just remind, so the 5G is still in the process of standardization. The standards would be complete later on this year and maybe around mid 2018. So you will start seeing the networks from 2019 onwards, right? So if we summarize all these different technologies we learned about, and this is a good picture which from European Commission, which I'm using. So 1G was mainly designed for voice, right? And we looked at amps was one of the standards. 2G was for voice as well as data, really really little amount of data, but the main emphasis was still on voice. So you moved from brick phone to smaller mobile phones in 2G. In 3G, we moved to smartphones. So we had a bit higher data rates, not great data rates, but a bit higher data rates compared to 2G. The smartphones became usable after we had 3G. 4G was just like 3G, but much more better. It was probably the first true mobile broadband technology. You could have dongles with your laptop, and they will work as you would have like with wired connectivity. Uh, and It's the most popular technology now. 5G, we are expecting a lot. So a fiber like experience. Again, it's a very tough ask. Fiber like connectivity with a wireless technology is very difficult to achieve, but that's what the standards are expecting in theory. So I hope you liked this presentation, and these are different links which you can actually visit when you have time. And please provide us some feedback, whether you liked it, what was missing. If you found some mistake, please feel to post a comment to correct it. And goodbye until next time.